Good morning and welcome to Innova Systems 2013 What's New for SolidWorks. We're going to start straight away with varying dimension pattern. So we'll go ahead and switch over to SolidWorks and we'll take a look. So feature patterns are common in all modelling tools but tend to be limited to creating identical copies of a feature at identical spacing. In SolidWorks 2013 these limitations are eliminated. So we'll see how the feature actually functions by taking a look here and editing this one that I've already created. So currently along the top no options have changed really. We specify a direction to pattern along and a distance between the patterns, and obviously a number of instances here as well. And I'm patterning in two directions here with the same spacing. The thing that's different towards the bottom is we now have a box called instances to vary, and this allows us to make modifications to the geometry as we're moving along in either direction. So once this box is turned on, you'll see here that we can adjust the direction 1 increments if we need to, and the direction 2 increments down the bottom. In this particular example though, we've actually specified a feature dimension here, which is the length of the slot at 20mm, to increment by a dimension of 5mm over every instance, and the same is true for the direction too. If I turn on the full preview here, you get to see the full impact of that change. Because the slot is constrained by its centre point, the length adjusts equally either side of the centre line. So you can see we can get some quite nice effects there with this tool. So we'll just accept that pattern and we'll take a look at this in action. So we've got a slot over here that we want to pattern in a number of different directions. So I'm going to go ahead and I'm going to start the linear pattern tool. And what we're going to do is we're going to select the feature that we want to pattern, which is this slot. You'll see it allows us access to the dimensions that control the size of the slot. So the first thing that I want to do is choose a direction, which is going to be this way, and the dimension there is going to be 30mm. Okay, and we want 4 instances, like so. If we just put on a partial preview here, we'll see what's going on a little bit better. So the next thing I want to do is specify a second direction, which is upwards, and again at 30mm. And here we'll choose 3 instances there as well, like so. If we come down to the bottom here and start the instances to vary box, I can then fill in a direction 1 increment should I want to. So here I'm going to change that to 10mm, and you'll see that each instance then adjusts itself by an addition of 10mm over the number of instances. We can also at this point select in the feature dimensions to vary box here and then select a feature dimension that we want to alter, which I want to be the 15mm slot length, and I'm going to change that by an increment of 5mm. So we can do that within the flyout windows here, or alternatively in the property manager on the left hand side. We won't see any change until we switch to a full preview, and then we should see the implications of that change. If I come towards the bottom here, the direction 2 increments I want to alter, and I'm going to change those by 30mm. I'm not going to alter the geometry in this direction, but what I am going to do is show you another option here, which is the ability to override individual instances should we want to. So here I can click on this instance and I can modify it individually. It allows me access to the evaluated dimensions at that point, so I could then come in here and make a change to that dimension and make it 150. If I accept that, we'll see that we now have our varied linear pattern. Okay, excuse me. So that's varying dimension pattern. We're going to switch over to Alex now, who's going to talk about multiple contour thin extrudes.
In SolidWorks we now have the ability to do multiple thin extrudes. Let's take a look at the command. So first thing we'll do is we'll just zoom in on this sketch here and have a look at the sketch. So you can see here the sketch consists of several single lines. Now in previous versions of SolidWorks it was not possible to extrude these lines as thin features all within the same command. They had to be done in separate commands, and this certainly proved quite frustrating for me at times. you can see now in 2013 it is possible. We'll also find here that we have access within the extrude command to all the end conditions for direction 1 and direction 2 on the right mouse button menu. In this instance I'm going to go up to body in both directions. Another nice enhancement is with regard to equations. You can now generate equations in the property manager of features. If I'd have wanted to set an equation up in this box here in previous releases, I would have had to complete the feature, access the dimension from the graphics area, and then create the equation. Now I can start off an equation just by typing equals. In this instance I'm going to link it to the global variable width, and you can see that solves. With regard to equations, there has been some improvements made to global variables in as much as you can now add the units after the global variables. This just ensures that when you do change your unit system, the extrudes stay the same size and stay proportional with the model. So all in all, some good improvements there. And now switch back to Ed.
Thanks, Alex. So the next thing we're going to take a look at is interference detection. There's been some improvements in 2013 in this area. So we'll switch over to SolidWorks and we'll take a look. So when performing interference detections on an assembly in previous releases of SolidWorks, certainly ones like this with multiple holes and fasteners, we're often faced with a large amount of interferences. You'll see here that we've got a reasonable list of interferences. This tends to be a result of the hole wizard using the drill diameter and the fasteners using the major diameter of the thread shank. So in previous releases we sort of dealt with this by creating a fasteners folder, and that would position all the fasteners in that folder, and we would effectively ignore those for our interference detections. However, in 2013 we now have a new option, which is the ability to create a matching cosmetics threads folder. It just deals with the whole situation of interfering threads in a nicer way. So if we create that matching cosmetic threads folder here, you'll see that we actually only have 2 matching cosmetic threads within this design. All the other ones are actually interfering. So we'll need to delve in a little bit deeper to see what's going on there. So we'll just come out of interference detection and we'll take a look here at this particular fastener, and we can see that that's listed as an M8. If we take a look at the mating component, and we'll just edit that and take a look at the tree, we can see that that's listing an M6 tapped hole. So there's a mismatch between those 2 items. Obviously it's a nice quick process to make a change to that, so we'll just edit this to an M8 just so it matches the thread. We'll just select that like so. And if we stop editing the component and return to an interference detection, we'll calculate it with the matching cosmetic thread folder set to on. We can see that we've obviously got a lot more matching cosmetic threads. We still end up with a couple of interferences, so we'll just take a look at those just to establish what they are. And we can see that there's actually an interference between the top of the bolt head and this handle in the middle, something that would have been overlooked in previous releases of SolidWorks. So quite a nice improvement there, and something that we would need to address. One of the other improvements to the interference detection system is the ability to show ignored interferences across multiple sessions of SolidWorks. So here, if I turn this on, basically what this means is that there's certain interferences that we can ignore. So we can right click and say ignore. Let's take this one for example. These ignored interferences are now saved with the file. So when you reopen the file, or a colleague reopens the file, he can choose to show the ignored interferences, and they are retained across multiple sessions. So we'll just switch back to our PowerPoint, and Alex is going to take us through some hole wizard and cosmetic thread improvements.
Okay, so on this model we have some hole wizard holes. With regard to how these are displayed, we see the annotative cosmetic thread represented by the circular line, and also the shaded cosmetic thread, as you can see, represented inside the hole. Now, a common question we get asked in support is it possible to turn off this annotative cosmetic thread? The answer is yes, but it would also turn off your shaded cosmetic thread, and many customers didn't want that. Now in 2013 we have the ability to just turn off the annotative cosmetic thread. We simply right click on our annotations folder, go to details and turn off cosmetic threads. As you can see, shaded cosmetic thread stays active and on. There have also been some improvements to the cosmetic thread feature. If we zoom in on this shaft, you can see that there's been a chamfer applied to the edge. Now, in previous releases, when we would add a cosmetic thread, we would generally, if it was a blinding distance, apply it prior to the chamfer just to get the correct call out for length. We now don't need to do this. We just add a cosmetic thread as normal. We'll select our edge and set it to blind, and you can see that we now have an additional box called start from a face or plane. So we can just start from a specific face. Let's just adjust the depth to what we want. Press OK, and that completes the whole the cosmetic thread. Now if we go side on and double click the cosmetic thread feature, you can see that the dimension is taken from the correct face, therefore your call out will be correct. Let's go back to the assembly and we'll just edit this part within the context of the assembly. Okay, we have some improvements made to Hole Wizard holes. We'll just launch the Hole Wizard, and what you'll find is that we now have support for dowel holes. When defining a dowel hole, we can define the size, the fit, whether it be nominal, clearance, transitional or press, and we can also define hole fits and shaft fits. We'll just set this to through all and place our holes on. So we'll place them in the exact same way as before, and then we'll open up this part and have a look. Okay, so there's our dowel holes. If we now make a drawing from this part, and we'll drag on a couple of views from our view palette, like so, and we'll have a zoom in on this top left hand view here. So you can see first off it's retained the annotative cosmetic thread even though we turned it off in the model, and similarly further down the dowel holes are marked with the appropriate dowel symbol. We now have a couple more controls, either converting or saving these views as something else. So if we click the view first off and access its properties, you can see that we have an additional box in here called Save View As. That will allow us to save a view as a DWG or a DXF file. You also have the choice to export only model geometry, so with that unchecked you would get all the annotations, dimensions and markups. Similar tool to that is now the ability to convert view, and you can convert it to a sketch or a block. So let's just replace this view with a block. You can see it takes all the edges of the model and turns it to block geometry, which is no longer associated with the model. This can be good for sharing your drawings. If you send these drawings out to someone and your views are saved as blocks, you won't need the reference files. It could also be good for archiving versions of your files, and also it reduces the overhead of the drawing as well. Okay, back to Ed.
Thanks Alex. So we're going to take a look now at some new sketch functionality with the support for Conics in 2013. So we'll switch over to SolidWorks, and we've got a reasonably curvy shape on the screen here at the moment. Just before we get into Conics though, I just want to explain a little bit about what they are for those of you who aren't sure. So a conic can be either a circle, an ellipse, a parabola or a hyperbola, and effectively all they are is a section through a cone on a plane, as you can see from the images in front of you there. So we now have the support for conics in SolidWorks sketching, so let's go ahead and we'll take a look. So I've actually put these onto my S key here, and they work very similar to any other type of sketch geometry in that wherever we go we can infer relationships to other areas of the sketch. So here I'm going to place a relationship down and then one at the top here, and I'll just infer a tangency to that line coming out at the top. So you'll see here I can place the conic down like so and then adjust its size moving left to right and then place it down again. Where these are very effective is when you want nice flowing curvy geometry. So we'll turn on the curvature combs for this conic here just to see, or just to show you how we can adjust these, move them around and understand the curvature that is within those conics. So you'll see there quite nicely we can get a good transition from the other conic into this one. If we take a look at this one here over on the left hand side, I'll just turn the curvature combs on this one as well. We can actually drive the conic by a dimension. That dimension is the row value, so here we can just type in another size and you'll see that obviously adjusts the conic to suit. But we can also then manipulate the conic as well, so depending on what kind of transition we want from one area to another, you can see using the curvature combs the influence that change has. So if we just position that like so, and we'll go ahead and we'll exit the sketch, you can see here we can get some really nice curvy geometry using the conic tool in 2013. Okay, we'll switch over to Alex now, who's got some detailing enhancements to take a look at.
Okay, so we'll take a look at some detail enhancements. First off, we'll look at centre lines and centre marks. So we have a view here and I'm just going to add some centre lines in the traditional way. Like so. Now, the improvement to centre marks is you can now default them to sit on a layer. So if we look at our options, document properties, centre lines / centre marks, you'll see that you can define what the centre line layer defaults to and what the centre mark layer defaults to. These can be the same or different. We now have some options of, or further options of how we control what layer something sits on. You can find that you can now right click on an entity and change its layer from the right mouse button menu. So we have access to all the layers there, and you can even launch the traditional layer dialog box from there as well. We have an additional option within the dimension property manager within tolerance precision. We can now link the precision with the model. This just ensures consistency of how many decimal places are shown between the dimension in the model and the drawing. We'll just go ahead and select some of the diameter dimensions. Within leaders we have some additional options with break lines. If we just turn that on, we now have the choice to break just the extension line, just the dimension line, or both. So I'll leave those both on, and you can see that as I drag this 2x60 dimension through, it automatically breaks those dimensions for me. Adding a note underneath the geometric tolerance has been improved. Before you may have had to create an annotation and group it with the geometric tolerance box. You can now, by accessing the geometric tolerance box, go to the below frame box and then just add in the note. And you can see that moves with the dimension. There's been some improvements to add in dimensions to notes. So if we double click this note to edit it, what I want to do is just add a dimension here. Now we now have the ability to zoom in and out while editing a note. So you can see I can zoom in and the note stays active. We'll just select this dimension here and you can see it's added to my note box. So before you may have had to drag the dimension near the note box in order to do those. We also have some improvements to borders, so I'm just going to add a box border around this. We have this additional padding option which just allows us to pad the cells like so. We can also do this with individual letters in our note, and we have the same padding options there. We have some improvements made to tables. When we reduced the size of a column, what we found was the row height automatically adjusted to suit it, but if we was then to drag it back, it would stay the same size, it wouldn't decrease at all. You can now see that the tables automatically size their cells based on the text, which is very nice. We have a new option with regard to importing model geometry, so let's just go in and insert some model items. The new option is to import just tolerance dimensions. So you can see as I click on that, it just adds the dimensions in with the tolerances. And there's been some improvements to the arrows on radial dimensions. So if I was to drag that down like so, you can see the arrow stays on the outside. And quite often what the user would do is click on this button here to send it inside. You now have an additional option in your document properties where you can attach to arcs and point away from dimension with your smart arrows. So if we turn that on, you can see that as I drag that in, the arrow always points away from the dimension itself. Last update here is to baseline dimensions. So these now behave very similar to ordinate dimensions actually. If we want to add to a baseline dimension scheme, we can just right click, select add to baseline and pick on the relevant edges of the model like so, and it will just be added to the scheme. We also have the same options now with regard to spacing these out. We can access the flyout here and then just change that to whatever value that we want. Okay, so some nice enhancements there. We'll now go back to Ed.
Okay, thanks Alex. We're going to stick on a detailing theme now and take a look at a new tool for drawings called Section View Assist. So we'll switch over to SolidWorks where I've got a drawing here that requires a couple of section views creating. In previous releases, section views could be quite time consuming, and they involve the creation of sometimes complicated sketches. In 2013, section views are now a streamlined and interactive process. And there's actually just one button for all section views. So we'll go ahead and we'll take a look. So the first thing I do is start the section view tool, and then you'll see over on the left hand side the property manager opens. I get a choice of which direction I create my section view, whether I'm creating an aligned or an angled section view. Here I'm just going to start by placing the start of my section at that point. You'll see I also get a nice little flyout here that asks me whether I want to create some jogs or multi-jogs or an arc offset. I'm going to stick with a single offset here and we'll just go ahead and we'll take a look. So I can click on individual points of the model like so. I can then add additional jogs on if I want to, like so. We can continue on that theme, so we'll just place another one here and go back to the centre. And that's all we want to do. So once we've completed that section, you'll see the section view scope box appears the same as it always did, and we can just say OK at this point, and then we can place our section view down over on the right hand side here. So quite nice and straightforward, very quick to create. We'll just place that down and you'll see we can get some reasonably complicated section views very quickly. If we take a look over here at this view, I want to create an aligned section view. The workflow is exactly the same, so we'll start the section view tool. We just select that we want to choose an aligned section view and then bring it into the view that we want to create that on. we click to place where we want the center point, and then at this point we would place where we want the start to be, and then you'll see now we can choose where the angled line needs to go. I want that to be positioned there. Again, following on an offset theme, I can add an arc offset. So you just place where you want the start of the arc offset to be, and then where you want it to finish, and then that will allow you to generate that section view very, very quickly. So we'll just position this section view down on the right hand side of this view, like so. Okay, finally for section views, another one that's commonly done is a half section. So if we toggle on the option to produce a half section view, we get faced with the standard sort of options in terms of which segment we need to section. So here I'm just going to choose the upper right hand corner. All I need to do now is just position onto the view, say OK to the box, and then place down where I want my section view to be, and I've almost instantaneously got my half section. So a really nice piece of functionality there, just to enable us to speed up the process of creating section views. We're just going to stick with me for a moment and take a look at some improvements to balloons. So we'll just switch back over to SolidWorks and we'll take a look. Hopefully. So on this drawing here, I just want to talk a little bit about some functionality improvements for the balloon systems. So we're going to take a look first up at the top end here, and we've had a couple of additional options included for us in terms of what we can reference in a balloon. So if I start a balloon here within the text option, well, firstly I'm just going to turn that to none. Within the text option we can now access the file name. I can place that down onto the component, and you'll see that now what happens is it actually drops the file extension away from the name, so it just gives us a little bit of better functionality there. One of the other things that we can do is also reference the part number as listed in the bill of materials, which is quite nice. So again, if I place a balloon down on the same component, you'll see there that we can reference that information. What I'm going to do now, I'll just keep the appearance of the balloons the same by using the format painter just to copy that border onto those other two balloons. If we take a look down here at this bottom view, we've got a nice isometric view here showing us a number of components which have been ordered sequentially, as was the functionality that was brought in last year. What we can do now is, if I switch over to or if we open the assembly, actually we may have the facility to turn on additional components, or you may add additional components to your assembly, and then what we would find is that the balloons would be out of date in some respects. They wouldn't include the new components. So if we switch back to the drawing sheet here, you'll see those additional components have been added, but they haven't been ballooned. So we could obviously follow a manual process to add in those balloons, like so. So we'll just position a couple of those there, and you'll see that their numbering sequence falls outside of what we've already organised. If we pre-select a view and start the auto balloon tool, we now have the ability to use some functionality within here. So we can actually resequence the existing balloons, functionality that was brought in last year, but this will include those additional balloons. So you'll now see that they've been renumbered to 4 and 5 to carry on with the sequence. But what we can also do now with this tool, which is new for 2013, is actually replace the entire set of balloons. So here I can say that I want to replace the entire set of balloons with a new one, and I get faced with the same options as if we were to create these balloons from scratch. So you'll see there that picks up all the additional components, and we've still got the functionality of magnet lines to reposition those quite nicely, like so. Okay, we're going to switch back to Alex now, who's got a new tool to show us called Intersect.
So here we have a wireless router, and we're going to change the top casing. So let's just open that. So you can see here we have the original solid for the top casing, and if I just show the surface, this is what we want to use to change the shape of the top of the casing. So let's just section through there and have a look in closer detail. So you can see that the profile of it is slightly different. and also we have this additional Wi-Fi section cut out of it as well. So in previous releases of SolidWorks, it would be a relatively straightforward process to use that surface to replace that top. It would have probably been the case that you would have deleted the top face of the solid body, then knitted the new surface to the original body, and then formed a solid out of those. The Intersect tool basically streamlines that process, so let's just take a look at it. So we'll launch it from the features menu here, and we'll select the bodies that are intersecting each other. We then click on Intersect. That just intersects the model into different regions, and you have a choice here of the regions that you wish to exclude. So what we're going to do is just pick some of those regions, and you can pick them directly from the graphics area or from the flyout here. We also have the option in here to consume surfaces. That just ensures that we don't get any stray surfaces floating about in the graphics area. Press OK. And you can see that completes as expected. Let's just take a look at the section view of that, and you can see the profile matches exactly what we wanted it to. Okay, so in summary, the Intersect tool streamlines many of the processes that you may go through when doing complex models. Back to Ed.
Okay, thanks Alex. So we're going to take a look now at some configuration enhancements in 2013. So we've got a configured assembly here on the screen. We'll go straight ahead and we'll take a look at some of the improvements here. The first one is in design tables. So for those of you who use design tables in your configurations, there's been a number of improvements here. The first thing I'm going to do is I'm going to edit the table in a new window. So we'll just let that open. One of the first improvements that's been made is to always bring this add rows and columns message box always to the forefront of anything that you're doing, so it doesn't get lost behind other windows. You know, in previous releases this could get lost, you weren't necessarily aware that it was open, whereas now it's always active and right at the front. We don't actually want to add anything here, so we're just going to say OK. The next improvement is that the Excel window will always maximize itself. This just ensures that you're instantly ready to work as soon as the design table's open. We haven't got to reorganize the interface or anything like that, which is really nice. It just makes things a lot easier to do. One of the other improvements we have is data validation in cells, like for example here, this configuration cell. So this is referencing the configuration of a particular component in the assembly, so a number of configurations exist within that part. If that is the case within your assemblies, you will now see a data validation box within Excel. These are added automatically by the system, so you'll see that we can scroll through any of these boxes here for components that contain multiple configurations and access those configurations. This makes life really nice and easy if we're to copy and create a new configuration here. I want a 4-inch variant, so I can very quickly just select from each of the drop downs here the 4-inch information that I want, like so. I actually want to change the suppression state here of this clevis pin, so we'll change that to resolved. And very quickly I've created a configuration. So the addition of data validation there in configurations is very nice. We'll just go ahead and we'll close that table, and the system tells us that we've generated a new configuration. So if we just activate that configuration, you'll see that we have our new variant of that assembly. Sticking with the design table theme, if we just open a component and take a look at the table that's included for this one here, so again we'll edit it in a new window, and we'll just allow that box to bring itself to the forefront for us and just say OK there. data validation has also been included in the materials box as well. So here if we select a particular material for a configuration, which this is 8" none here, we can grab from the quick list of materials that is customizable within SolidWorks and very quickly select those. So you'll see here that all that information is available for us as well. If we close down that table, we'll just take a look. We haven't added any configurations here, but if you remember, I've changed the material on 8" none to brass. So if we take a look, you'll see we've now got a brass rod, and you'll see that the material has also changed within here. When I talk about the quick list that we're selecting from, it's this customizable list on a right click here, so that's your commonly used materials. Okay, if we just switch back to the configuration manager for a moment, there has been some other enhancements here, and one of those is regarding the caching of configuration data to the file. So you'll see here we now have a green tick or a minus symbol next to each of the configurations. What this means is whether or not the state of that configuration has been cached in the file. This can be quite important for things like EPDM and e-drawings. If we just access some of these configurations here, you'll see that it will put a green tick next to it. So if we were to save the file, the system wouldn't need to rebuild to activate that configuration. If there's a minus symbol, basically it means that it would have to rebuild to activate that one. There's a couple of other improvements related to this. We can right click on any particular configuration and add a rebuild save mark. All this means is that every time the file is saved, that particular configuration is rebuilt and stored with the file. So for easy access, it may be that you've got particular configurations that you're in very often, that kind of thing. We can also do that from the top level as well, so we can actually mark all configurations or specified configurations, for example, and we can also remove the purge the data for all configurations from here as well. There is a system option in SolidWorks under performance here to purge cached configuration data. So on saving a file, if this option is turned on, it would clear all that data, so they would all return to minuses unless you'd added one of those rebuild save marks. So quite nice in terms of speeding us up there. So we'll just return to our top level assembly and we'll take a look at the final improvement for configurations. That's related to exploded views. So if we just add a new exploded view here, we'll just select a couple of components just so we've got a few bits and pieces selected, and we'll drag those out like so just to create an exploded view. What we can do in 2013 now is add multiple exploded views per configuration. So you'll see now that I have the ability to add another configuration or another exploded view for the same configuration. So this is almost a limitation that a lot of people wanted to see changed. In 2013 we now have the facility to do that. So you'll see under this one configuration I now have multiple exploded views. So there we can see another really nice improvement to 2013. Okay, we're going to switch over to Alex now, and he's going to show us some improvements to library features and weldments.
Thanks, Ed. We have seen several great enhancements here, and we'll start with support for multi-body library features. So in previous releases, when dragging in a library feature, it would automatically try and merge all the bodies that it connects to. So this, obviously in a weldment environment, was not good. Now what I'm going to do here is just drag in a library feature. And we'll just zoom in on this leg here. So we have a multi-body library feature here, and we'll drag it in, and it works in exactly the same way. You drop it on the placement plane, and then you define the relevant edges or references that it needs to solve. You have full operation of changing the dimensions, so perhaps here I'll come and change the offset to 25 like so. And that just generates a single body foot mount in our graphics area. Now what I'm going to do with that is just pattern that, so we'll take our sketch and we'll do a sketch driven pattern in that solid body. Okay, so if we examine the cut list, what we find is we have 4 bodies at the bottom, which we've patterned, and we'll just go ahead and update that cut list such that it groups them together in the same folder because they are identical. We'll then rebuild the model, and you can see the BOM updates to show an extra row. Now, with regard to description, because this wasn't a structural member, it doesn't automatically generate a description for it. Now, in previous releases, quite often you would access the folder, access its properties, and then manually type in a description there. Quite often as well, that description would relate to weight. SolidWorks 2013 has automated this process. If we rebuild the model again, if we just right click on the cut list, we have a new option to create a bounding box. Now what this option does is it fits the smallest bounding box it can around the solid and then generates values of thickness, width and length. So if we have a look at the properties of that same folder, you can see that we've now got additional properties: 3D bounding box thickness, width and length and volume. The other thing that it does here is it collates all of those values and places them in a description cell and prefixes it with the term plate. So you can see here, if I just rebuild again, those options, that description comes into our cut list. Now, the nice thing about this is they're fully parametric as well. So for instance, if we go ahead to 400 and then just rebuild that, you can see that the gusset description updates to reflect those changes. So all in all, some great changes there with weldments. We'll switch back to Ed.
Okay, thanks Alex. So the next thing we're going to take a look at is some sheet metal improvements. Okay, the first one I want to talk about is that the tree structure for multiple body sheet metal parts has now been reorganised. So in 2012, what you'll remember is that you would end up with multiple sheet metal features scattered in and around your tree at the point at which you created the sheet metal body. In 2013, what happens is they're all categorised under one sheet metal folder. So you'll see here that we've got the 3 sheet metal features underneath that folder. The same is true for the flat patterns as well. They're now all underneath one flat pattern folder. So if I unsuppress a pattern here, you'll see that the number of flat patterns in my design now increases to 5 to reflect the change that I've made. This functionality does happen automatically. One of the other things we've seen an improvement on, certainly last year and again this year, is forming tools. So last year the whole forming tool interface was overhauled. We now have the addition of insertion points for forming tools. So I can just reposition that insertion point there onto the origin, and we'll just switch back to our sheet metal enclosure. I'm going to add that forming tool on here. Now the addition of the insertion point just makes it nice and easy for when we want to position these forming tools in place. So we'll just position that like so. We'll just use the arrow keys to rotate it. Tab will reorientate it for us, and we'll place that down like so. With the position placement now, because we have an insertion point, it's a lot easier for us to get those in the correct orientation, and also to dimension to them as well if we need to. Okay, so we'll now take a look at some drawing improvements with respect to sheet metal. So we'll just go ahead and we'll open this drawing, and we'll just let that load up, and we'll take a look up here. So one of the first improvements, which I won't show you necessarily, is the ability to configure the line display for sheet metal bend lines and edges and things like that, which is quite nice. The other improvement we've had is to bend notes. So these have been completely restructured now. You'll see we can have full control over whether they display or not display from the property manager for the view, but we can also configure how the bend notes display. So I can completely delete the structure of those by default, and then start to add in the bits that I'm interested in. So here we could put in bend order, bend allowance. You know, we can stack multiples therein of if we want to. So we'll just put on the normal information here, like so, and just say OK. So that's quite nice. You can also save away the structure that you want for the bend notes in the document properties as well. One of the other improvements we've got is the ability to combine bend notes, so we can now merge those together. You'll see I've now merged that note together with this one, which is quite nice. Another improvement that we've seen is for tables. So for a bend table now, we can choose whether we have alpha or numeric labelling on those. We'll just go ahead and we'll place that table down. Another sort of addition here is that we can now insert multiple additional columns into this table, and if we double click here we can access all the information that we want to access. So maybe we want bend order, for example. So some quite nice improvements there for sheet metal. So we'll just switch back to the PowerPoint. We're actually going to stick with me for a little bit longer, and we're going to talk about multi-body costing. Okay, so costing was a piece of functionality that was brought in last year, which a lot of people really liked. It's part of the professional suite of products. So if anybody's interested in costing, that's the version of SolidWorks you would need to run to actually get this. In 2013 we've seen some additions to costing. What I'm going to talk about is the addition of support for multiple bodies. So on the screen here at the moment we've got a multiple body sheet metal part. It's actually got 10 bodies here which we're displaying. So if I start the costing tool, it opens up on the right hand side, as is the same in previous versions. It's still based on a template system, but we now have what's called a multi-body template. So this would just allow us to specify which sheet metal template we're using and which machine template we're using. Towards the bottom here we get the ability to choose which bodies are costed. So if we just have a look down here, it's isolated 2 bodies that it can't automatically categorise. They're actually cast feet, so we want to exclude those from the costing process because they're bought in items. So we'll just click exclude there. Once we've done that, we can then begin our cost estimation. If we didn't exclude those, we could choose which type of body they were to cost, and then the green box would become active again once we'd done that. So if we begin our cost estimation, what the system is going to do, it's going to take each of those components individually from this design that we have, and it's going to perform a costing on those based on the templates that are selected. So what we should see at the end of this process is a summary of a total cost for that component. So we can see towards the bottom it lists out our total cost. We can set that cost as a baseline, as is the same on previous versions. I'm just going to set it as a baseline here so we've got something to compare against. If we come over onto the left hand side, it will show us all the sheet metal bodies and their associated costs. So here we can see we've got a seat. If you double click on that seat, it will actually open the specific component and it will show us all the information relating to the cost of that part. I actually want to make a change to this and add in a logo cutout on the back of it, which I'm going to do. If we return to our costing module over on the right hand side here, what we can do is we can update the cost for that individual component, which it will do very shortly. So we can see that we've made a 5% increase to that component. If we return over to the left hand side, there's a little button at the top that allows us to return to the multi-body environment. So what that's going to do then is adjust the overall cost for the total component that we're looking at. We've also got some other nice options in terms of adding custom operations. So here maybe we want to add a welding, maybe 2.5 hours welding we can add in here. These are all template driven as well, and we can just ensure that we get really accurate costs for our components. So some quite nice additions there to costing in terms of multi-body. If we switch over to Alex now, he's going to talk about some improvements to the machining side of costing.
Thanks, Ed. We've seen some nice updates to the machining costs in interface, namely that we now have support for turn parts. So what we'll do is we'll come into this flange shaft here and we'll start our costing module off. So as before, we select our template and then it works out the cost of the part based on the template. The additional option that we have here is that within the stock body, as well as block and plate, we now have cylinder. As soon as you select cylinder, it will see it as a turned part. Okay, now if we review our costs here, what we have are turn operations. So you can see here that it's picked up on outer diameter turns, inner diameter turns, inner diameter grooves and outer diameter grooves, and again that's all driven from the template. Also we have some keyed holes here and some standard holes. So you'll see in here that we also have milling operations and hole operations. Now these would be done across multiple machines, and that's exactly what costing does for us. It works out those different operations and then defines a different machine for them. So you can see here that we have a mill for 3 of the operations, and then a machining centre for the turning operations. We also have much more control over how these setup operations are grouped together. So for instance, I can group one of the outer diameter turns in the first setup operation and then just remove that setup operation cost, like so. Now if we switch to the backplate, we also have some additional improvements to just machine parts. So first off, if we look at the mill operations, we have our pockets as normal, our holes as normal, but we now have a new volume feature, and the volume feature is basically there for exterior part milling, so you can see it generates a price for that. Also what we'll find is that we have this hole here, and we can now on the right mouse button define whether that is milled or drilled, and if we want we can also drag it into a folder to specify that as well. So some nice updates there. Back to Ed.
Okay, thanks very much Alex. So the next thing we want to look at some improvements for is Circuitworks. So we'll switch over to SolidWorks and we'll take a look. So for those of you who don't know what Circuitworks is, it's part and parcel of the SolidWorks Premium package, and it gives us the ability to import ECAD files from electrical programs. So in 2013 we now are offered a higher level of support for industry standard ProStep, IDF and PADS files, and it also provides a more accurate representation of boards. So I'm just going to select one of those files here and open that up into Circuitworks, and you'll see Circuitworks is in itself a separate program. So it will convert that ECAD data for us to view here, and the first thing that I want to talk about is this additional support for multiple layered boards. So if we just open the properties pane here, you'll see over on the right hand side it will tell us what type that board is, and also the thickness as well for each of the particular layers within it, which is really nice. We've also got support for non-plated, plated holes, and another addition for 2013 is the support for traces as well. So it will actually show us the traces on the board. So if we view the bottom here, you can see all the traces between the components for that PCB. We also support copper pads now, also vias and any filled areas as well. If we look towards the bottom, sort of standard functionality in Circuitworks is the ability to view which of the components are going to be generated by the system. So you'll see here we can select the component and view it on the ECAD data. One of the additions now for 2013 is the ability to specify which type of component it is. This can actually be read through from the ECAD file as well, but we do have the ability within Circuitworks to override this and specify whether it's electrical or mechanical. Standard functionality again is anything that doesn't or has information missing will actually show with a little warning triangle. So if we take a look at this component as an example, you can see it's missing a Z height. So if we just fill in the information there for that and this other additional component, we're sort of ready to build the 3D model from this ECAD data. Now that would be done by using the build model button within Circuitworks. I'm actually just going to close Circuitworks down here, and we'll take a look at a model that I generated earlier, as it takes a little while. So here you can see the support for traces, copper pads, and the additional functionality really makes a difference to interpreting that ECAD data into SolidWorks. And you can see that it looks really nice in 3D as well. So it's just helping to bridge that link between the electrical designers and the mechanical designers. So following on from that theme, we now move into what we're calling our new product section, and Alex is going to talk about a new product called SolidWorks Electrical. So we'll switch over to Alex.
Okay, so SolidWorks Electrical is a new product that is split into two packages. We have a 2D and a 3D version, and we'll start by looking at SolidWorks Electrical 2D. So SolidWorks Electrical 2D is a powerful schematic design software aimed at electrical engineers. It allows users to collaborate on several electrical projects simultaneously. It allows you to generate comprehensive schematic diagrams, generate automatic reports and BOMs based on your schematics, and include manufacturing and information instructions. Okay, so we're in the line diagram tab now, and we're going to add a motor to this section. So to do that, we'll just come in and we'll insert a symbol, and you'll see from here that we have a vast library of symbols that we can add in at this level. So we'll go to motors and we'll pick the symbol that matches the other motors there. So let's just select that and drop it on the page. Now as soon as we drop it, we're asked to define the manufacturer parts and circuits. So to do this, what we're going to do is just search an extensive database for motors. So if we just search for Leroy Summer motors, you can see here actually if I hit the drop down that there is, you know, a vast amount of manufacturers on there, and that's updated on a regular basis. So if we hit search, based on our search results, it will come back with these motors, and we'll just pick on that one there and then just add it to the list like so. Press OK. I want to add this motor to the circuit, so we can just use our simple draw cable tool to connect the two pictures together like so. At this stage we can also define the cables and wires for this. So we'll just come in, we'll add some terminals, and then just by simple dragging and drop define how those terminals are connected like so. Okay, now it's also important here to note that when we are doing anything at this level, when we go to the schematics to do our traditional multi-line diagrams, that they will be linked with what we've defined in here, so we don't have to redraw the same thing twice, and you've got consistency throughout your design. Once this is done, we can have a look at some of the schematics that we've got in here. From the schematics and the line diagram, you can generate a bill of materials like so, and your lists of wires and various other bits and pieces. Okay, now one thing that you can't do within SolidWorks Electrical 2D is work out accurate cable lengths. It's just something that can't be done in a 2D environment. So we can look at how we can use SolidWorks Electrical 3D to do that. So let's switch to SolidWorks, and SolidWorks Electrical actually appears as an add-in in our list here. Okay, so what we find is that SolidWorks Electrical actually embeds itself into SolidWorks seamlessly in the panes here. So we've got some in the left-hand pane and some in the task pane. We've also got a Command Manager tab for the Electrical 3D tools. Okay, so here we've got our packaging line, and the components in here are represented with a tick box if they're present. Okay, so I need to add some components in, so let's take a look at this one for instance here. Now you can just right click on that and insert it and then choose the appropriate file, or alternatively you can associate something that's already in the assembly with that component in electrical. So if we click on associate, anything that's selectable isn't shown as transparent. We'll select that box there, press OK, and you should see that the green tick is now next to it. We also have some nice alignment tools for aligning components on a panel. So if we go to align components, we're going to space them evenly across with a spacing of 10 mm. And you can see they shifted across like so. Okay, now we haven't got all our components in here, but we should still be able to create a route at this stage. So if I come in and I just click on the route wires option, you can actually use this with SolidWorks routing, which is available in Premium. If you don't have the Premium package, you can use this 3D sketch route tool, which is what we're going to use now. If I hit OK, what will happen is, based on the 2D electrical data, SolidWorks will create a 3D sketch representation of the wires, showing how everything connects to each other. It's also at this stage where the lengths of the wires are worked out, and then we can send that information back to the 2D package. So there's our wires there. They're just sketch lines, so they can be hidden with the hide show sketch options there. To update the 2D version, we just go to update bond properties. That sends the information back to 2D. And then we'll just switch back to 2D, and now we have accurate lengths for our bills of materials. If at any stage you do want to create a report, that's not a problem. We just go to our project report and then just define what we want to create a report of. So if we just add a report for PLC inputs and outputs, and then generate drawings, you can see it puts our report at the bottom there, like so. And if we at any stage want to export any of that information, we can go to our import export tools and export files as DWGs or PDFs. Okay, so all in all, a very interesting package. We'll look forward to working on this a lot more in the coming months. And now we'll switch back to Ed.
Okay, thanks Alex. So we're now going to look at the second of our new products, which is SolidWorks Plastics. So SolidWorks Plastics is a simulation tool to study the mould flow of plastics into a plastic cavity. But before we take a look at that, I just want to show you a couple of new tools for plastic part designers. So the first one is the addition of a new tool or a new assembly feature called Swept Cut. So this has now been ported across, and we can use this as an assembly feature. So within this folder here, I've got a two-dimensional sketch that I want to cut a sweep across a 3D sketch path. So you'll see we get all the standard options in terms of the feature scope and whether or not we propagate the features to the parts. If we add that on there, you'll see it does a really good job of doing something like that. The next piece of functionality I want to talk about is mounting boss design. So this is something that has been available in SolidWorks for a long while, but it's been refined in 2013. So, you know, as you guys will remember from last year, we have the command search. So if you're looking for something, you can type it in here. So I'm looking for mounting boss. I'm just going to start that tool. You know, really nice piece of functionality that up there from last year. So within this tool, it is something we've had for a little while, so I'm just going to position things in the normal way. So we'll just grab hold of a couple of reference entities here, and then we'll talk a little bit about what the updates are. So the first update is we now have the ability to include a hardware boss rather than just a pin boss, so that's quite a nice addition. We're just going to select a face for this to mate up against. Hopefully we can get one. Yes, we can. Okay, so we've got the same sort of options we had here in previous releases. A couple of new ones for fins just towards the bottom here. We can now align those against existing geometry. We've also got some controls here over the chamfer detail and also the length. The length is something that we did used to be able to configure, but sometimes it wouldn't necessarily terminate against a body that it was going up against very well, whereas in 2013 that has been looked at and does seem to behave very well. So here we'll just adjust some values to the chamfer angle, and we've sort of finished our mounting boss off. So we've completed our mounting boss, so we'll just stop editing that component and we'll take a look now at SolidWorks Plastics. So if I open up this particular part here in its own window, we're going to take a look at how the functionality works. So it is treated as an add-in, so you can access it from the add-ins menu and turn it on, and it does appear in your command manager as a tab. So the workflow for SolidWorks Plastics is very similar to a lot of the tools in SolidWorks, and specifically the simulation tools. So the first thing we need to do is create a mesh, and we can do this automatically or manually. The manual controls are very easy to navigate, so if we take a look at those, the first thing we need to do is, well, we'll just reuse the mesh parameters there. We need to choose a cavity that we want to mesh, and there could be a couple in this design, but there's actually just one here. We then specify a mesh triangle size and also how we deal with the refinement and also any transitions. So I'm just going to leave those options as they are and click mesh, and you'll see it's very quick in terms of actually creating a mesh. Obviously the more refined the mesh is, it's going to take a little bit longer. So if we just skip through onto the next thing, so we will follow the tree down in terms of structure. The next thing we need to do is choose a material that we're going to inject, and SolidWorks has a very comprehensive database of these plastic materials. These are specific to the plastics module. They don't come with standard SolidWorks, and nor can we select them in standard SolidWorks. They include a little bit more data in terms of how the material is going to flow and things like that. So we're going to leave this set to a generic ABS here, but there's about 5,000 materials in here, and we can choose to sort by family or company, and it also has a search facility as well, which is quite useful. So if we just say OK to that, we can move on to the next bit, which really is specifying a gate. So the gate is where the plastic is going to flow from the injection moulding machine into the cavity, and we can position this just by choosing an edge or a face, for example. So we'll just choose here and then adding that gate into position. So I'll just click the green tick there, and that's really all we need to do to set up our simulation. The next stage is to run the simulation, so we'll do that. We'll just replace the existing results and we'll let that run through. So while that's running through, you'll see we do get some partial results appearing on the screen, and you can see the type of plot results that we can get over on the left hand side as well. Just to give you a little bit more information about SolidWorks Plastics, it is available in two versions. We have SolidWorks Plastics Professional, which is more for the plastic part designer, and then we also have SolidWorks Plastics Premium, which is more geared towards mould designers, the people who are actually creating the mould tools to manufacture these parts. We do have some spec sheets available for all the new products, so Alex has talked about SolidWorks Electrical. We've also got some SolidWorks Plastics data sheets, and if you do need any more information on the tools or some pricing information, then please get a hold of one of us or one of the sales guys during the break. Okay, so that's nearly finished now, and we should be able to take a look at some of the results. What you will see is it collates the information as we're going through the simulation. So the maximum injection pressure is listed at any given point in time. It tells you what the percentage of the fill is in terms of being complete. Okay, that's finished now. So if we just take a look at some of the results over on the left hand side. So the first one is a fill time plot, which will show us exactly how the plastic is flowing through the cavity, and you can see it will give us a completed time there in 0.41 seconds. One of the other nice options we have is the ability to show air traps, so we can see where the air is being forced into certain areas by the plastic. So this may give us an indication of areas that could be damaged during moulding or may need venting, for example. We can also display the weld lines as well, so where molten plastic moves around an object and then reforms, it causes a weld line. These are obviously a cosmetic problem if they appear on sort of high shine surfaces, so you may need to be aware of where they are and adjust thicknesses and geometry to move those around your design. We can also look at cooling time as well, which is quite an important one, just to understand what the overall cycle time for a plastic moulding is going to be. So we'll leave that simulation there, but we'll take a look at another one that we've got over here, which is a cavity mould. So the front and the back part of this pedometer really need to be moulded in the same mould at the same time, but something that can be quite complicated to calculate is actually getting the two moulds to fill at exactly the same time. So this is something that a lot of people do manually, but can be quite time consuming. In SolidWorks Plastics Premium, we have the ability to do what's called a runner balance analysis. So here we have a runner system which feeds the plastic into both the cavities, and we have this runner system drawn out like so. That can be solid model geometry if you want to, but there is also a runner design system within the tool which will allow us to perform these runner balance analysis. And basically what it does is it calculates what the adjustments in terms of the runner sizes are for either cavity to ensure they fill at the exact same time. So that kind of thing can be really useful for the mould designer. Okay, so that brings us to the end of the first session. I hope you've enjoyed yourselves. We'll be back a little bit later for session 2. Thanks very much for watching.